my hint for you guys is that, remember when we did the deer? We needed just to know the starting point and the rate, and then we could get anything, couldn't we? Remember that?
Mhm. Yeah.
Once you have that, because remember with the deer, it was like, oh, I got my starting point. Okay, so if I wanted 15 years later, I just go 600 times 1.045 to the power of 15 years, and I'm done, right? So here, instead of 600, our starting point is 2. And we're talking about rats instead of deer, right? So it's 2 rats, and instead of 4.5%, it's 71%, right? Now, how many months in a year? Alrighty, so what I want you all to remember, anyone from home as well, is look, we already did this with the deer. Now we have rats, right? It doesn't matter, deer, rats, who cares, right? With the deer, we started with 600 deer, right? Okay, so that was 600. Now we're starting with how many rats? 2 rats. So that's that. So it's the same thing. With the deer, it was 4.5% growth rate. Remember that? With the rats, it's 71% per month, right? Growth rate. You with me? So we just do the same thing, only we have different numbers. That's basically it. So you've got 2 rats, and by the way, 71% is actually 71 over 100, which is actually 0.71. So you go 2 times 1.71, because you don't just do 0.71, because you gotta keep the 2 rats that you began with, basically, and you keep what you've got the previous year, and then 1 year, and remember, this is 71% per month. And 1 year is 12 months. So it needs to be to the power of 12. And so in a calculator, 2 times 1.71 to the power of 12. And we'll round that to the nearest rat. And if you plug that in your calculator, you should get around 1250. You get that? And then for 2 years, that's 24 months. 2 times 1.71 to the power of 24, right? So round that to the nearest rat, and what do you get?
A lot of rats.
Okay, 781,514 around. I'm going to round that to the nearest 1,000 rats. I'm going to say, so 781,513. I'm going to say that's rounded to 782. Okay. Because nobody says, hey, I estimate your population is going to be 781,513.7 rats. That's silly. That doesn't make any sense. That's a dumb thing to say, isn't it? Like, if you were actually estimating this in real life and saying, if we don't do anything about the rats in 2 years, these 2 rats are going to become about 700. Actually, it's more like 780. That would be even better. Yeah, sorry. I'm going to ask you all to round it to just 780. About 780,000 rats. You know what I mean? Or even 800,000 would probably be better, because it's a ballpark figure. It's an estimate. Does that make sense? Are we clear on this, on the math and everything? We okay with these 2 answers? And this 780 would be rounding to the nearest 10,000. Make sense? You okay with that? Okay, so what we looked at is perhaps a realistic increase in rat populations if they have everything they want. So that means food, unlimited amount of food, shelter, lots of area to expand into, water, all the things rats need, and other healthy rats to breed with and everything. So what we found was, after 12 months, about 1,250. You can see that about there in this diagram. And after 24 months, we're up to about 780,000, right? Now, the reality is that populations do not just continue to grow exponentially, because if they did, in 3 years' time, you'd have what? for almost 500,000, no, almost 500 million rats. I mean, there's got to be, it just can't go on, right? And so anyway, and the reason is because, look, there's not going to be an unlimited amount of food for the rats. There's going to might be some disease. There's got to be some predators out there. People have to be doing some sort of pest control. The rats might eat each other, whatever, right? But if under ideal conditions, the population can grow pretty quick. And this just kind of gives an idea. They have a gestation period, means between their conceiving and their pregnancy basically lasts about less than a month, so 21 to 23 days. So that's time between conception and birth, right? And they have 5 or 6 rat pups in each litter, and they can have 3 to 6 litters. One rat can have 3 to 6 litters in 1 year, right? And then the average lifespan of that mother rat would be about a year. So in any case, that's where the 71% average came in, but that's only in perfect conditions for the rat, right? Okay, so I've popped over to desmos.com. I'm going to use the free graphing calculator just for fun. And our population of rats is y equals, start with 2. And the increase at 71%, so 1.71 every month to the power, and the little hat that's above the 6 to the power of t. So this is the increase of the rat population per month, and this is real. I'm going to hit the tool button up here. The x-axis is months, and the y-axis is population. And we found after 24 months, we were up pretty high, close to 1 million rats. I think it was. And so, yeah, X will just do that like 26 months or something, just so we can show that graph. And so I've just done that to try to show. Now this is our hockey stick, rat population. Worst case scenario, they have all they need, and look at that population just shooting up like that. And by golly, after, it's really taken off, isn't it? So for example, here's your 24 month nightmare scenario. About 780,000 rats after 24 months, right? That's what we calculated, right? Now, of course, once again, this is an exponential model for a population, and populations cannot just keep going on forever. That's silly, right? And so let's have a look at what it would really be. So the black is like your exponential, and your pink here is your logistic. So really the population is going to look more like a logistic curve. The rat population will go up until there's some sort of limiting factor, such as they've used up all of the food they can eat or whatever, right? And so the rat population, of course, it might go back down again if people get it under control. So in any case, that's just showing the limitations of the exponential model, is that, of course, populations don't just go on forever. They have to taper down at some point, either for some reason, right?